We'll start this module with basic water quality terms and concepts, which you may have covered in other courses, and we'll also start to talk about some water quality criteria. Water quality describes the chemical, physical, and biological characteristics of water. That's the most basic definition. It's worth saying, though, that the term water quality in itself doesn't actually in itself have a negative connotation. We just happen to talk about water quality more when the water quality is bad. We don't see water quality popping up in the news as much when the water quality happens to be good. Taking each part of this definition individually, the chemical characteristics involved with water quality have to do with substances that dissolve in water, like DO, dissolved oxygen, or metals, nutrients, pesticides. And then also chemical characteristics involve things like pH of the water and redox or oxidation reduction potential, which we've covered in earlier lessons. Physical characteristics have to do with color, odor, temperature, taste, and turbidity, or how cloudy or how much sediment there is floating in the water. And then biological characteristics involve living organisms like E. coli or fecal coliforms, all the way up in size to insects, plants, and fish. And from a biological standpoint, or an aquatic biology standpoint, it's often the biology that we're trying to preserve in the water. A lot of our water quality efforts involve making sure the stream or the lake has good enough water quality to support biological life. So even though we study here nutrients, nitrogen, and phosphorus in our water here in Illinois, a great example is that we're actually working towards making sure the biological life in the Gulf of Mexico can survive. So if you don't have the chemical and physical parameters of water quality right, the biology won't be there. In a general sense, what are the major types of water pollutants? The biggie is sediment. One of the biggies is sediment. There's no other pollutant that occurs in the same mass or the same amount comparable to sediment in our streams here, our streams and our rivers and our lakes here in the United States. We're not going to talk much about sediment in this class because that's more of a surface runoff concern. And I've already defined for you particulate versus dissolved pollutants. So we've talked about particulate versus dissolved pollutants in an earlier lesson. But I do want to note that we differentiate in our lab and in many water quality labs dissolved pollutants using a 45 micron filter. Anything that goes through that 45 micron size is considered to be dissolved. So anything that goes through it ends up being dissolved. Side note, I've said before, subsurface drainage tends to be very clear. The soil is a really good filter, and so we generally don't have a lot of particulate pollutants in tile drainage water. Heat is another type of water quality concern. There are certain fish, like trout or salmon, that are particularly sensitive to heat. A good example of when you would have heat pollution is if you have a factory or a plant that has cooling water that they have to send out to a stream out of the plant. And the cooling water that they're using to cool some of their processes might be warmer than the stream. So that's an example of heat pollution. Metals can obviously be of concern in terms of water quality. Metals like arsenic, cadmium, chromium, copper, lead. Many of you will remember the lead in the drinking water in Flint, Michigan that happened a couple years ago. We also can be concerned about manganese, mercury, nickel, selenium, silver, and zinc. The interesting thing is that some of these metals are also trace elements required for humans, as well as plant micronutrients. And so there's this juxtaposition of these metals are good in certain conditions, certain situations, but we don't want them getting into our water in excess amounts. We're going to talk a lot about chemical pollutants in this class. For us, that's nutrients like nitrogen and phosphorus. People are also very into right now pharmaceuticals, personal care products, hormones that get into our water system via wastewater. These personal care products and pharmaceuticals, hormones, they are typically present in very, very low concentrations in waters, like parts per billion or parts per trillion. And it's really only advances in analytical equipment over the last 20 or 30 years that have now allowed us to analyze for these types of pollutants at such low levels. And then lastly, bacteria can be an important water quality concern that can actually make people sick. It's important to differentiate what's a point source and what's a non-point source because that's very common water quality terminology. A point source is pollution or poor water quality that's emitted from a pipe, from a point. This is typically factories, plants, wastewater treatment plants. The important thing with point sources is that they are regulated. Point sources like factories and wastewater treatment plants have to meet very specific criteria. They have permits that they have to meet, and they have to meet specific criteria and monitor their outflows very frequently to make sure they're not in violation of those criteria. Non-point sources are in contrast to that, sometimes called diffuse source. It's pollution that doesn't come out of a single pipe. So it's like agricultural runoff, sometimes stormwater runoff, typically urban runoff from lawns or golf courses are considered non-point sources of pollution. So here's a question for you. Is a tile drain, an agricultural subsurface drain, a point source or a non-point source? Tile drains are specifically excluded in the Clean Water Act from being considered point sources. They're specifically written into the Clean Water Act as not point sources. That is, they're specifically not considered waters of the U.S. So good to note, even though it looks like a pipe, tile drains aren't point sources. Now all this begs the question, what is good water quality and what is bad water quality? How do we make that determination? In the earliest days, humans often settled near freshwater bodies for obvious reasons, and in those days if the water was polluted, that often ended up being a matter of life and death. Fortunately, it's not typically a matter of life and death for us today. This question today is answered in the term of impairment, using the term impairment. A body of water is considered impaired if it fails to meet one or more water quality standards. So next obvious question, what's a water quality standard? Water quality standards are set based on the concept of a designated use. So you have to know the designated use in order to set the standard for that water body in order to know if that water is impaired. So this is a multiple step process. What are designated uses? Like you see from the US EPA, getting this concept of a designated use for a given water body is critical so that you can establish the right standard and then evaluate if the water body is impaired. The three biggies for designated uses here in the US are drinkable, fishable, and swimmable. Designated use of drinking water, and then uses of fishing and swimming. We'll start with drinking water. Drinking water has very specific set, enforceable, federally enforceable water quality standards associated with it. This little screen clip of a PDF I'm providing you, these are the National Primary Drinking Water Regulations. Again, enforceable standards, federally enforceable standards for water quality of our drinking water. And this PDF is in your course material. These drinking water standards are set based on a concept of MCL, maximum contaminant level, MCL. MCL is the highest level of a contaminant, highest concentration of a contaminant is what they mean, that's allowed in drinking water. MCLs are set as close as possible to the MCLG, that's the second definition, set as close as possible to the MCLG using best available technology and also considering the cost that it requires. Like I said before, MCLs for drinking water are federally enforceable standards. It's very important to our country to have drinking water meet a strict bar, obviously for human health reasons. Now the second definition on this slide is maximum contaminant level goal. And this is important to understand even though we hardly ever talk about the MCLGs, just in common water quality circles, unless you're a drinking water person. The MCLG goal is the level of a contaminant in a drinking water below which there's absolutely no known or expected negative human health effect. So you can see that comparing MCLG and MCL, the MCL takes into account a little bit of a practical aspect, because we're also taking into consideration, well, what can our technology achieve in terms of cleaning that drinking water and how much is it going to cost? So there's an important distinction between MCL and MCLG. Now moving to fishable and swimmable, there's generally not federally enforceable standards for these designated uses compared to drinking water designated use, unless a total maximum daily load, a TMDL, has been established for a certain water body. We'll talk about TMDLs in the upcoming lesson. These fishable and swimmable criteria tend to be recommended criteria. For example, this is from the US EPA. They have ecoregional nutrient criteria for nitrogen and phosphorus. It's important that you read this disclaimer. Again, this is not a standard, it's not enforceable, it's a recommended criteria. For us, sitting here in East Central Illinois, I'm going to pull our ecoregion off of this map. I've provided you this map and the associated tables in your course materials. I'm going to pull our ecoregion off of the map so you can see my mouse. We're in East Central Illinois in ecoregion 6. It's this orange one. Corn Belt and Northern Great Plains. And so in the associated tables, the US EPA provides ecoregion nutrient criteria, recommended criteria to avoid eutrophication for lakes and rivers. That's the top table. And then for lakes and reservoirs, and then for rivers and streams. For us in ecoregion 6, you see our total phosphorus recommended criteria is 37.5 micrograms of total phosphorus per liter. What is this in milligrams total phosphorus per liter? 37.5 micrograms TP per liter equals 0.0375 milligrams TP per liter. So just divide by 1,000 there. Another note I'll make is that the criteria for lakes and reservoirs is all lower than the criteria for rivers and streams, and that's because rivers and streams are moving. They're getting aerated more naturally just because they're flowing, and so the criteria can be a little less strict for rivers and streams than for lakes and reservoirs in terms of nutrient concentrations that may lead to eutrophication. I also want to point out, this is very relevant for us right now. As a part of our Illinois nutrient loss reduction strategy process, we'll talk more about that in the next lesson, we've developed our own nutrient criteria for the state of Illinois. And I'm providing you this report in your course material. I really just want to pull out this table though from the executive summary of the report here. So you'll see this is for wadable streams. See you next time.